Myslíš, že je to dobrý? Nevím, co to je.
Jo, ale toto problém. Proč to není systém obrazovky? Počkej, ale to možno mám rozlišení. No, aha. Tak je to, že?
Můžeme? Ty časy, co ti tam budu ukazovat, to je na tvůj talk, pak budeš mít ještě 10 minut na otázky, jo? A ještě ukážu out of time, tak to znamená, že ještě pak máš 10 minut na otázky.
Takže 40.
40 dohr, 40
tak to
a 10 na otázky.
Jo, takže o 40 by se mohl končit. Super, dobré. Jo.
Mikrofon je tady, když tak, kdybys pak ty otázky zopakoval. On má velký dosah, takže pohodě.
Dobré.
Hello guys, please welcome our last but not least speaker in this room today, Peter Schiffer from Red Hat, who is going to tell us something about OpenShift on Google Cloud Platform.
So, welcome everyone. As was said, my name is Peter. I work in Red Hat in Atomic OpenShift team, specifically in end-to-end sub-team of Atomic OpenShift, where we work mostly on the reference architectures for OpenShift, which will be I talking about today. So, slides are available in GitHub if you would like to follow on your own or check them out later. And let's do this. So today I will be talking about what we do in our team, that reference architecture, why we are doing it, and mostly how. Now, reference architecture is, or what is it, or what we want to provide. We would like to provide highly available production quality OpenShift architecture, which leverages native infrastructure of cloud providers. Now, we are working with more cloud providers, and specifically it's those 5. For every cloud provider, there is a different reference architecture. All of them are done within my team, and I specifically am working on Google Cloud Platform architecture. So, now, why we are doing that? I guess mostly because it's fun, and otherwise because you would have to do all of this by yourself. Now, we as a Red Hat as a Red Hat company, we provide OpenShift product, which has some installer. There is like basic and advanced installer. Advanced installer uses Ansible, and it can pretty neatly deploy OpenShift on something, right? So installation of OpenShift itself is pretty, I guess it's pretty well done. Now it's mostly automatic, and even the OpenShift is pretty complex applications. The installation of OpenShift is pretty easy. But now we have various infrastructure providers, As I've told before, there is Amazon Web Services, there is OpenStack, GCE, Microsoft Azure, or VMware, and every infrastructure has its own specific features or ways how the infrastructure do stuff. And now, if you want to deploy highly available production-ready OpenShift, you need to configure your infrastructure in some way, right? And because of OpenShift is complex, your infrastructure will needs to be complex as well. So this is basically a reason why our team was formed like almost 2 years ago, where we found the problems with or let's say other way, where we want to fix issue where it was kind of too complex to deploy OpenShift on some provider from those before. So we are working on reference architecture, which is kind of a guidance, or it's really a PDF document which describes the infrastructure of the provider. It shows all the necessary parts which are required to have highly available production ready OpenStack installed, and it guides you step by step what to do, how to do it, and why to do it. So while this document is pretty neat to have, because you don't need to find out all the stuff by yourself, because the providers are really quite complex, and even if in our teams we were working for the first initial release of the reference architecture for almost a year. So this is great, but it would still let the most of the work on you. So you have to go to do, I don't know, Google Cloud Console, and you would need to click there all the instances, all the networking, and everything, all the configuration you will have to do yourself manually via web interface or from the command line interfaces. Most providers provide some command line tools for configuration. So to fix this as well, we are also providing some code which basically can do all of this for you automatically. So in GCE, we have currently shell script combined with Ansible, which with one command can deploy all the infrastructure, deploy OpenShift, and do some configuration of post-installation task for you. Basically, it's done within half an hour or so. The paper is the reference architectures are official. They are reviewed by plenty of people, and they should be high quality. Code, however, is not officially supported by Red Hat, but we are doing we do like unofficial support. So if there is an issue, if there is a pull request, we do review and stuff like that, but we don't guarantee anything. All right, so this might be end of the talk, but it wouldn't be so great. So let's make a new agenda, and let's talk about how we provision infrastructure and about the infrastructure itself, specifically about the Google Cloud platform, how we deploy OpenShift, and how to configure it and do some post-installation tasks. So about the infrastructure. Before we try to provision it, let's describe it. Or let's talk about stuff we are using in our reference architecture and which is used by OpenShift. Kind of most simple, or the first feature I'm going to talk about is just Google Cloud DNS, which provides DNS service for the cloud. Good thing or very important thing is that it's scriptable, so you can configure it automatically from command line. this is like one of the cool features of hosted cloud providers, specifically GCE, AWS, and Azure. It's pretty good also for OpenStack. But for example, if you have VMware and you have, you are managing your own infrastructure and you don't have solved DNS by you don't have solved DNS, like it's not possible to automatically configure it. You have to do it manually because there's no way how to make a super general reference architecture to handle all of the DNS configuration, and we don't want to provide DNS server for your infrastructure because we don't know nothing about it. So with GC, it's pretty cool. You don't need to care about. Only required thing is that for the domain you are going to use, you need to point it to the name servers of Google, and that's it. Also, that's I think one manual task kind of you need to do before deploying the OpenShift and infrastructure. Next, we are using Google Cloud Virtual Networking. Without that, it wouldn't work, of course. We are using single network for all instances, but the traffic is heavily controlled by firewall rules. We control all ingress and ingress for every instance. So every service can communicate only with specific ports of every instance. So so we're trying to be as secure as possible. In GC, firewall rules requires tags. So basically, you need to take every instance in the GCE, and the rules are bound to the tags. So the firewall rules also never works with internal IP address because there's no need for them. And if you have multiple instances with the same type, like masters or instances or OpenShift nodes, it's really easy to configure the firewall in pretty easy way. Now, we're also using the Google's object storage where we store images for the registry. This is supported by OpenShift, so we really just set it up for OpenShift installer and let it work its way. And the last and most used part of GCP is Google Compute Engine, which provides virtual machines, disks, and everything related to the cloud virtual machines you would expect. So now let's talk about GC, as this is the most important and biggest part of GC, of the reference architecture. Now, for base images of operating system for every instance, we are using custom images because even though Google provides RHEL-based images, they doesn't contain the sufficient subscriptions, so it's not possible to install OpenShift there. Now it's possible to register the Google provided RHEL instance to your account and attach to your subscription, but the instances created from the official Google's Red Hat images are more expensive, so you would end up being double charged for the one service, right? So in our reference architecture, we are using official RHEL 7 KVM image provided by Red Hat from Access Portal, which also needs to be downloaded by the customer, and it's used by the shell script which deploys the architecture. So that's the second manual step or prerequisite. We automatically convert and change the image so it's accepted by Google Cloud platform. Now, before talking about other instances used by OpenShift, we are using one more instance called Bastion, which is only instance with public SSH access. And we are using the proxy for SSH proxy to access all other instances, and we are also deploying OpenShift from there. So this is this instance has two use cases. One is security, so no other instance have public SSH access, and the second use case is the installation where we can easily provide known environment for deploying OpenShift. We could deploy OpenShift on GCP from user's workstation, but we don't know about Ansible version he has installed and stuff like that. So to minimize problems and use a known environment, we are doing it this way. But there will be probably another option how to do it. We would like to provide the installation or the Ansible with installation script as a Docker container. So it would be possible to deploy the OpenShift from anywhere with known configuration. But that's still on to do, and it's not ready yet. Alright, so now about the instances. Google provides two neat features. One is instance templates, where you can pre-configure how your instance will look like, meaning that you can specify machine type. Machine type contains number of CPUs and number of RAM your instance will have. And you can also, in the instance template, specify which image will be used to create instance and what disks will look like and stuff like that. So you don't need to create that for every instance separately. And instance groups. This feature, I'm not aware if OpenStack has it or AWS, probably not. But it's really nice where basically for instance groups provide a single entity to manage number of same instances. So to create instance group, you specify instance template and how many instances you want there. There's this basic configuration of instance group, and when you create it, Google Cloud or Google Compute Engine will create the required number of instances automatically. It supports health check, so you can easily create auto healing. It's used also for load balancing and stuff like that. For now, in our reference architecture, it's not possible to add additional nodes to OpenShift cluster for now. But later we will be adding this feature and we'll be utilizing the feature of instance groups where it will be enough just to change the number of instances in an instance group, and the cluster or OpenShift cluster will be automatically adjusted. But it doesn't work yet. Now, probably the the hardest part was figuring out networking and load balancing in GC, because from the architecture, let's see, if we want it to be highly available, we need at least 3 masters, ideally in different zones. They are here. We have 2 infrastructure nodes, which are the regular OpenShift nodes, but they are running only infrastructure applications. That's router and registry. They don't run any user applications. And last part is any number of application nodes which run user applications. So now to make it work, we need to load balance traffic for masters and nodes. respective routers. So, because only routers are accessible from outside network. Any traffic for the application running in OpenShift has to go through the router of OpenShift infranode. So, but but for the masters, there are two types of traffic. One is public traffic, which is going from users to OpenShift console, whether it's web access, whether it's browser-based access, or whether it's a command line utility. And a second kind of traffic is internal to OpenShift between masters and nodes. Now, OpenShift is using certificate-based authenticity, so every node in OpenShift is identified with its own certificate, and masters can authenticate that certificate, and they can say that, yeah, this is valid OpenShift node. But those certificates are usually not like publicly valid certificates, so when you would try to access the OpenShift masters through those certificates, you would get warning that it's like invalid or insecure certificate. So to solve this problem, we are using SSL proxy in front of masters for public connection. So there is a single valid certificate facing the public network, which user sees when connecting to the masters. So that's this one. Now there is two network-based load balancings. One is for master for internal traffic, and one is for routers from public traffic. There are also two registries running on every infrastructure node, but this service is automatically load balanced by Kubernetes, so we don't need to care about it. Also, this is the current version of reference architecture, but in the next version there will be 3 OpenShift infranodes, because OpenShift 3.4 introduced a new sweet feature called, I don't know, something like zero data and upgrade. And for this feature to work, we need 3 infrastructure nodes, so the update is without downtime. So it will be changed, but we just add an additional infrastructure node. All right, so let's say we somehow know what we need to load balance, and let's discuss how we will do it. Basically, Google provides 4 types of load balancing. First is HTTPS load balancing, which works on HTTP layer. We originally used that for web access, but we found out that web console is using WebSocket, so there's no way. So we switched to SSL proxy. This was pretty fine, and it's enough for our needs. There is a single certificate in Google Cloud platform, which is served by Google, and the nodes or instances instances don't know about it, and that's perfectly fine. And the 2 other load balancing methods are network load balancing and internal load balancing. We are using network load balancing for both internal master access and external router access. This is basically because when we were creating the reference architecture, internal load balancing didn't exist yet. So we will be probably switching for internal master access. We will probably use internal load balancing. The network load balancing, the main difference between those two is that the network load balancing requires public IP, which is again fine because we are filtering all the traffic with firewall, so there's no really a security issue, but internal load balancing will be probably better. So now you probably think, all right, it's not that bad. It's like 4 times. What can go wrong? Nope. There are a lot of things you need to configure, but if you want any of this to work. So for SSL proxy, SSL proxy is a little bit more complicated than network load balancing. Basically, for every load balancing Google, you need something called forwarding rule, which binds public IP address with target proxy or target pool. Target proxy is used. I think the SSL proxy is very similar to HTTPS proxy. There needs to be SSL proxy similar to HTTPS load balancing. There needs to be some proxy which contains the certificate and will end SSL connection. And you can choose if the connection between target proxy and backend services will be encrypted or not. So you can still use on master instances. We are still using HTTPS certificates, but they are internal and they are not valid publicly. But the connection is encrypted. So the forwarding rule contains IP address and target proxy, which represents where this IP address or the traffic for this IP address should be forwarded. In case of SSL proxy, target proxy needs configuration of SSL certificate and configuration of backend service, which likely represents the instance groups or instances itself which will accept the traffic. Network load balancing doesn't contain the proxy, just a pool with instances. So it's a bit harder, but it's still not it, because you need to think about level of resource are you using, because the resources in Google Cloud Platform can be in 3 states or can act on 3 levels, which is global for everything, regional, which is local to region, and region is like Europe, America, Asia, and so on, and zone, which means, I guess, data centers or something like that. So you need to know that for SSL proxy you need global IP address, but for network-based load balancing you need regional IP address and stuff like that. It's kind of hard to put it all together. As well, there is I think it's required health checks for the backend services. So when health check fails, the traffic is not forwarded to the broken instance. For now, we are not using auto healing, but that will be a feature added later with option to adding additional nodes. And basically that's it about infrastructure. So once you configure all of this, you can deploy OpenShift. Yeah, and with regards to the infrastructure, it's kind of really easy if your infrastructure is running. So we are using advanced installation for OpenShift, which uses Ansible directly, and you can modify the parameters for Ansible and the advanced installation. Do you all know Ansible? Who worked? Please put your hand up if you worked with Ansible before. Nice, almost everyone. So I guess you know that there is one feature called dynamic inventory. There are 2 kinds of inventories. There are static and dynamic. Static inventory is like a text file, which contains all the hosts you specify manually, and dynamic inventory is basically a script which can query something and provide a group or provide instances and group of instances based on some specific criteria. GCE or Ansible supports a dynamic inventory for GCE, and it returns so it can return all instances and groups by tags. So we appropriately tag every instance, whether it's master, or whether it's infrastructure nodes or application node. So advanced installation can automatically recognize all the instances, and it can pretty easily deploy master services to masters and stuff like that. So basically that's it. We just provide some configuration file for an installation and it's done. We don't do nothing special with that. And last part of the OpenShift or the last part of the reference architecture is configuration of OpenShift and some post-installation tasks, which are all done with Ansible and which contain some specific configuration for GC. For example, OpenShift storage OpenShift storage supports GC's persistent volume, so we just configure that. We slightly configure firewalls on instances mostly for health checks. That's not done automatically by OpenShift installer. We set up some quotas, deploy registry, which is also not default, which is also part of default OpenShift installer. And we also do deployment validation where we try to create project in deployed OpenShift. We deploy some application, wait for it to come up and check if it works correctly. Then we'll delete it. So once you are the script finished, you have OpenShift installed and you know that it's working. If not, you will see some error messages and you need to debug yourself, but at least you know that it's something's not working. The validation also tests builds, so also the registry and the build service is tested and validated. So if you want to try it, for now you need Google account. Basically, it's free, and access to the Google Cloud platform. When you try to for first time, I think you have credit $300 to trial it, so you don't need to pay for that if you want to try. And you also need Red Hat account for Red Hat Enterprise Linux and OpenShift subscription. For now it's required, but we will be also working for a version with CentOS and OpenShift Origin. It's not ready yet. Again, it's something on our to-do, but we definitely want to provide that option as well. Now, if you have all these accounts, it's really easy. If you have the accounts, now you need the gcloud utility on your workstation from where you will be running the deployment. It's pretty easy to configure. You can install it with this super unsecure way, or there is also YAM repository and apt PPA repository for Ubuntu, so you can do it that way as well. And once your cloud utility is installed and configured, you just clone our repository with reference architecture script. You change the directory, configure one file, and run the script. So the configuration file contains plenty of configuration options. Most part of the reference architecture is configurable, meaning that you can rename everything how it's called in the provider, and you can also change size of the disks, change number of instances, and stuff like that. Also, you can configure the region and zone where your OpenShift want to be running and stuff like it. Also, the deployment script supports the revert option, which basically removes everything from the cloud created by that script. So you can test it, and if there's something not working, you can remove everything and start deploy again or stuff like that. So I have 4 minutes. I just show you the configuration file. Basically, okay, so I need to. Here's the repository with the referential architecture stuff. All scripts for all providers are there. There are also links for the PDF papers. Microsoft Azure is probably not published yet, but it's very close. There are also the code is already there, and reference architecture for OpenStack is somewhere else. I don't know where it's because within the reference architecture they are working also on better integration of OpenStack with OpenShift, so it has, I think, its own repository. So the GC script and configuration is here, and the file looks like this. Let's say basically this is the most important part, the configuration, which basically you need to adjust. There is the path for the rel guest image. There is the configuration for rel subscription and Red Hat account, gcloud project zone, and the DNS configuration. Right. You can also provide your own HTTPS certificate, or if you don't provide any, it will be automatically generated some self-signed. So you just so you can try just that. And OCP identity providers like provides the authentication service. By default, it's we are using Google Identity Provider, but you need to specify some your IDs and secrets. But you can basically change it to any authentication like GitHub, or if you are using any local identity provider service, you can use it here. And the rest of the file contains default services, which almost everything can be configured. If it's size of the instances, names, number of instances, and stuff like that. Also, there are all firewall rules specified here if you need to modify them or adjust them. Yep, basically that's it. No. So, do you have any questions? Yep.
You say that actually this reference architecture is not yet supported by Red Hat.
The code. The question is about supported. Whether the reference architecture is supported or not. The code, the scripts are not officially supported. We are providing them as a guidance, and you can use them at your own will if you want. The paper, I think, I'm not sure really now, but I think there is also a note that it's like guidance. You can inspire yourself, but.
So if you install OpenShift whatever way you want on Google Cloud Platform, actually you can open a case.
Yeah, definitely. Even if there is also a problem with the reference architecture, you can open the case for it, and we will handle it. But there are no SLAs and stuff like that because we don't really have the cloud provider under our control, and it can change any time and stuff like that. So we can't really provide support as we are used to.
And regarding the supportability of this reference architecture, what about the regional zoning and replay between the master, the etcd cluster and the running OpenShift master is working fine?
For masters, yes, we are using native HA. Before there was like you have to use AJ proxy, but not anymore. But yep, it works pretty fine. We don't. Yes, the masters are not yet divided in multiple zones for GCE. They are for AWS, but there was a bug in Kubernetes which prevented us to use them. But this is fixed in 3.4. So we will be updating the reference architecture. The support is almost ready for it. It's really just a couple of variables in the script, but we couldn't use it until the 3.4 is out. So. Any more questions? Yep.
Do you use any tool for testing OpenShift or Kubernetes or in this reference architecture, like Kubernetes conformance or this kind of stuff?
All right. So. The question is about if we are using some testing of performance and validation of this reference architecture. So we edit and we are adding continuous integration for the reference architectures. So the scripts are automatically tested, like every time you make a push and stuff like that. The first was AWS, and I think GC is already edited or is being edited. For performance, we don't do that by ourselves, but we have a team which is working on that and which works on OpenShift performance in general. It's in a sub team, and but we do work with them and we have them reviews and stuff like that. So we use their guidance. Any other question? Yep.
Is it the most mature or is it?
Oh, the most mature provider, you mean?
Reference architecture.
Oh, most mature reference architecture, right?
Yes, or is it?
Yeah. The reference architecture for AWS was the kind of first one, or we were like most or other architectures are following that one kind of, but they are every architecture is a little bit different. But I guess the best integrated architecture is definitely for OpenStack, because that's also our product and we can do much more for integrating the services. For example, on OpenStack, there is OpenShift is using OpenStack networking, so there's like not virtual networking on virtual networking, because OpenShift has its own SDN, software-defined networking. So yeah, basically that. If what we can use in the cloud, what we can use from OpenShift of the provider, we are trying to use it as, for example, the object storage and stuff like that. And in the end, we would like to use also the networking, like make it better and stuff like that. But there's a lot of limitation, and it's evolving in a time. But yeah. So and about like which reference architecture is like best. Really, if you can have your own OpenStack, so that's probably the best solution for a company. And for public providers, there's not like big differences. But it's true that Amazon or for reference architecture for AWS has some features sooner than others. Like adding nodes. I think the adding nodes feature is also already present in reference architecture for AWS, and for GC it will be added later. Stuff like that. But it really depends. For example, for Microsoft Azure, it's possible to load some file which will be displayed in the web interface, and you just click it that you want to deploy this, and it will deploy the infrastructure based on that file from graphical interface. But this is a feature of the of the cloud providers, so not all of them provide that. So it varies. Okay, any more questions? If not, thank you very much for attending.
I would also like to remind you that there are going to be lighting talks in all the tea rooms at 6. The schedule is ready and it's on the web and in the Android app, so check it and go take a look. And the party at Fleda starts at 7:30, I guess. But if you haven't got any tickets so far, I think you are out of luck because there are no more tickets.
Finito?
Super.
Jo, v pohodě, dal se to.
Paráda.
Jo,
There's a big sign for that. It's really hard to listen. And if you ask anyone, everybody knows it.
Maybe it's a good idea.
něco sám, tak se začali zvíjat. Je to dobrý.
Vypnul hudbu, keby sme tu nejako mali, ne? Vieš, ako to sú
Tak
lesson learns from akože spárov.
Experience.
Motivovať, aby si.
Teraz som si všimol, že to vypínala strašne veľa tých anteník.
Lebo to sú podľa mňa virtuál. Ja mám tiež napríklad router z kúpil od cedníku a v ňom sú dve sieťové karty, akože dve Wi-Fi a 3 anteny tam mám napríklad. Hej, s tým, že akože jedna Wi-Fi je napojená na 3, tam všetky 3 anteny a druhá karta je iba na 2 anteny z toho. A normálne sú keby vzdielané, tam normálne ešte to aj prepíja, čiže tam môžu byť ako keby niekoľko Wi-Fi. Je tam nejaký mixer, je tam nejaký akože niečo, čo mixuje ten signál, lebo to sú akože rôzne signály.